Okay, this is 7.3, number 30, and this is part A. And what we're going to do is we're going to take the region that's bounded by the lines y equals 2x, y equals 0, and x equals 1. And I've outlined that in orange. And we're going to revolve that about the line x equals 1. That's a vertical line. So I'm going to have to integrate with respect to y. I'm going to be using horizontal disks. They're going to be moving from here to here. Now where 1 intersects with y equals 2x, 2 times 1 is 2, that's going to be the point 1, 2, so I'm going to integrate from 0 to 2. And since it's going to be with respect to y, I have to solve it for x in terms of y, so y equals 2x, divide both sides by 2, x equals y over 2. Now it's a disk method, but since it's off the axis, I'm going to have to figure out how to find this radius, and this radius is going to be given by the right curve minus the left curve, and that's going to give me this radius here. Right curve minus left curve, in other words, the right curve, which is 2 minus whatever this x value is, will give me the radius of these horizontal disks. So this is a nice little method to do it, right curve minus left curve. So that's going to be right curve is 1, and the left curve is given by the x value being y over 2, and that's going to be my radius. And I put this in my general form. Again, this is disk, so I don't have any gaps there. And it's going to be integrating from 0 to 2 pi times r as a function of y squared dy. And again, my radius was over here, 1 minus y over 2. I took the pi out as usual. And this is all ready to take, well, I have to square it out, pardon me. I have to multiply this out. So use the just FOIL method. 1 times 1 is y, or binomial squared. 1 times 1 is 1, pardon me. 1 times 1 is 1. Minus, and then 2 times y over 2 is y, plus y over 2 squared is y squared over 4 dy. Now we're ready to take the antiderivative. The antiderivative of 1 is y. Now the antiderivative of y is y squared over 2, and the antiderivative of y to the third over 4. I'm sorry, y squared over 4. I'm getting ahead of myself. Y squared over 4 is y to the third over 12. I'm going to evaluate that from 0 to 2. And remember, the pi is still out in front, so I put a 2 there. 2 squared is 4. 2 cubed is 8. And 2 minus 2, 4 over 2 is 2, is just 0, so I just have 8 over 12, which is 2/3, so 2/3 pi. So that wasn't too bad. Now we're going to take this same triangular region, and we're going to revolve it about the line x equals 2. So now we will have the washer method. There we go. Okay, so there's my line x equals 2. Okay, draw a nice sketch. You should be able to make a good sketch because these are all straight lines, so use a ruler. This is my region, but I'm going to revolve it around this. So since it's 1 unit away from 2, this edge here is 1 unit away, I'm going to have kind of a cylinder in the middle. So I'm going to have kind of like this little triangular, this trapezoidal shaped figure rotated around, and that will be the whole figure. And I'm going to cut out this cylinder inside. Okay, so I have the general form for the washer method is going to be pi big R squared minus pi little r squared, all as functions of y dy. I'm going from 0 to 2 as before. So I'm taking this big volume, and I'm going to subtract or cut out that inside volume. So what's this large radius, the big R? Well, that's going to be, again, like the right curve minus the left curve. That's going to give me the big R. Right curve is 2, and the left curve, again, is the y over 2. And the small radius, the inside, is going to be the right curve minus the left curve, and the right curve is 2, and the left curve is 1. So just 2 minus 1, which is 1. So that's going to be my small radius. So I just substitute those in over here. So this is my big R, my big radius. 2 minus y over 2 squared minus the small radius. Again, I took the pi out as before. And what we have is we have to square this. So now we've got 2 instead of 1, so 2 squared is 4. Minus twice the product, so that's going to be 2 times y. Plus y over 2 squared is y squared over 4. And then minus 1 squared, which is 1. 4 minus 1 is 3, so I could simplify that. So 3 minus 2y plus y squared over 4. Okay, I'm ready to take my antiderivative. The antiderivative of 3 is 3y. The antiderivative of 2y is 2y squared over 2, and y squared over 4 is y to the third over 12, all times pi, and I'm evaluating that from 0 to 2. Now the zeros on all these cases cancel, so I don't really need to worry about that. So that ends up being pi, and 3 times 2 is 6. Those cancel, so I just have 2 squared, which is 4. And 2 cubed is 8 over 12. So that just ends up being 2 2/3. Pi times 2 2/3, and 2 2/3 is 8/3 pi. So that wasn't too bad either. Make sure you draw a nice sketch, label your axes, use some rulers. Always take pride in your work.